So yeah, we're students from SUTD, ISTD pillar. So we're seniors, and we ran this workshop a couple months back as part of the independent activities program. So we're very excited to bring it to a wider audience today. First of all, let's settle some logistics, right? So just make sure on your computer you have the following, right? Make sure you have Git installed. Make sure you have a working installation of Node.js, along with npm or yarn. And then lastly, just make sure you have a text editor you're comfortable with working with. All good? It'd be great if you could have some activity in chat. Very strange to talk to an empty room. So for the course resources, this is a course webpage, the GitHub repository. And this particular slide that you can find here, the slide that I'm using right now is on this link. Right. So throughout this course, we reference a few other sources. So primarily it's the Mozilla Developer Network (MDN) and then the Fireship.io YouTube channel. So to get on with the agenda, so today I'll roughly introduce the workshop, then have a quick introduction to WebSockets, and then we'll go through two tutorials. So firstly, building a simple WebSocket server and client. It just simply sends and receives messages. And then moving on to a more complicated use case, which is a group chat application. Moving on, we'll have browser APIs, explore a bit of browser APIs if we have time. And then Daryll will take over, and then he'll be talking about WebRTC, and then using WebRTC in our video chat application. So let's just get started, right? So this workshop is called the Real-Time Web Application Workshop. So what is a real-time web application? Right, broadly speaking, it's not a very well-defined term, right? So it's according to the Wikipedia article on it, it's a network web using technologies and practices that enable users to receive information as soon as it is published by its authors, rather than require that they or their software check a source periodically for updates. So the important point here is that a real-time web application would enable users to receive the information as soon as it's updated or changed. That's what we want to get from here, right? And the source from the bottom just tells us it's a very vague term, that the servers would push the data to the clients instead of the clients pulling it from the server. So with that done, let's move on to WebSockets. So WebSockets, what is WebSockets, right? So WebSockets is an Internet protocol. So what is a protocol? So a protocol, roughly according to my computer networking textbook, defines the format and order of messages exchanged between two or more communicating entities, as well as the actions taken on transmission or receipt or message. So it's just some kind of structure that defines how two parties should communicate. Oh, right. So moving on to WebSockets and HTTP. So WebSockets is an internet protocol, but the other protocol that powers the internet is HTTP, right? So HTTP is what's responsible for most of the web today. You go on your browser, you load a website, it's getting the information through HTTP, right? So these are both actually client and server protocols. That means when talking about different nodes, some of them are clients, some of them are servers. So typically when you go on a browser, your browser is the client, the server is somewhere in the cloud, and then they communicate with each other, and then they communicate through a request-response pattern, right? So HTTP is a request-response protocol where the client sends a request message to the server, and the server returns a response message. This is the only way they communicate, right? Request, then response, request, then response. No response request, the server cannot push things to the client. Any information sent to the client must be explicitly requested by the client, right? So with this in mind, and our previous definition of real-time web applications, which is the user or the client getting updates as soon as the update occurs, right? How can we get real-time behavior using a request-response protocol? So you can think about it. On the surface, it seems like it's very hard to get this kind of behavior, but in the early days of the web, people have come up with a lot of different hacks and tricks to try and emulate this kind of behavior. Mainly like short and long polling, or polling and long polling, right? So these are the two main methods used in the earlier web applications, and then nowadays you still use them as a fallback because they're well supported. So short polling is essentially the client periodically polling the server for updates. So you still have to request response, and yeah, so request response. If there is no updates, then the response is empty. It doesn't tell you there's no updates. If there's a update, then the response will tell you there's an update. It's the equivalent of the client telling the server, "You have anything new for me? You have anything new for me? You have anything new for me?" Right? It's very annoying. Wastes a lot of network traffic, right? Because if you don't actually have anything to send, then you're sending an empty response for nothing. The more advanced hack is called long polling, right? So long polling takes advantage of the fact that a HTTP request will wait for a specific amount of time before actually giving up. So what long polling does is the client makes a HTTP request to the server, and the server holds this request for as long as possible, not releasing a response until either there's an update or the time is up. So these are two hacks that people have used to really get real-time behavior, and it emulates it quite well, but not perfectly, which is where WebSockets comes in, right? So WebSocket connection is a full duplex connection, which means that the client and the server can both send data along the connection at the same time, without any requirements on the ordering, right? So you can see from the diagram here, the client and server establish a connection, and then they can send messages to one another, no problem, no ordering, no nothing, right? So the important thing here is that WebSockets treats sending data as discrete messages. So message data is sent either as a string or some kind of binary data format. So strings are strings, right? And then binary data types are array buffer blobs, array buffer views. But for the purposes of today's workshop, we'll primarily be talking about strings, be working with strings, right? So with that in mind, let's just jump into it. Let's get started with our first tutorial, a simple WebSocket server and a client. So the important thing to remember here is that we have a client, we have a server, and they send discrete messages to one another, right? So let's crack open GitHub, follow the link in GitHub, and just clone the repository. Yes. All right. So again, in this workshop, I hope everyone has some familiarity with JavaScript and Node.js specifically, and how Node.js creates modules and packages, how to package Node.js projects. So this is a Node.js project because we are running a server on the server side, obviously. That's serving a static web page that is sent to the browser, right? And you can see our dependencies here. We'll be using the Express library to serve our static pages, and using this WebSockets library to handle WebSockets. Right. So let's get to it. Let's roughly go through the code we have here. And of course, if you want more detailed notes, we can, let me see, where is it? I wonder if it's here. Oh, I don't have it uploaded. Oh well. Okay, it's pretty simple tutorial. Right. So let's just go through what's run, right? So there's a package.json. The main function is index.js, so this is our entry point to the application. So we run this server by running node index.js. Oh dear. All right, I didn't initialize. So always remember, after cloning, initialize your repository, initialize your dependencies. So I'm just gonna do that with yarn, install the dependencies. Node index.js. Right now I started a server on port localhost 8080. So here we have our client-side page being served to our browser. We have our server running on this thing, right? So what we want to do, or rather, what this particular code demonstrates is a simple WebSocket application using WebSockets, where the client side will send a string to the server. And then the server reverses it and then sends it back as a WebSocket message. And then the client, on receiving the message, it will alert the reverse string, right? So it's the quick. So now it's reversed. So you can see here, but we can't see here, but you see. So let's just roughly go through the code, see what's going on, and have some, understand some of the principles behind the whole thing, right? So over here, this is our index.js file. We're spinning up we are importing the HTTP module, start HTTP server. The path module is for path resolution. So just some standard stuff. Importing our external dependencies, WebSockets and Express, and then serve our static site with Express. So our static site is only this index.html here. And then start our WebSocket server. So at this point of time, let's get a bit into event-driven programming, right? So broadly speaking, event-driven programming is a programming paradigm where the flow of the program is determined by events. So basically, instead of the code executing sequentially, your code will execute based on events, right? And JavaScript is a language that's particularly suited to the event-driven paradigm because there's a whole event loop and it's doing all that good stuff behind the scenes. So all you need to think about is emitting events, listening to events, and then handling those events along with event data, right? So over here, we have WebSocket server with instantiated WebSocket server, right? So WSS on WebSocket, WSS is on, WSS is our WebSocket server. The on method, sorry, one sec. Oh dear, never mind. The on method basically allows you to listen to a event. So in this case, the connection event. The library will emit a connection event when a new another client connects to the server, right? And then we handle the event using our callback function, which takes a WebSocket object as a parameter. And yeah, so within this callback, we'll hook on. Now that we have our WebSocket object, this individual WebSocket object represents the WebSocket between the server and a particular client, right? WS represents the WebSocket between one server, one client. WSS represents the WebSocket object for the particular server. Yeah. So in this WS, so on this particular connection, we want to listen for messages, right? And then we want to handle those messages. So on message, it gets called with the message of the message sent through the WebSocket. So remember when we said just now, WebSocket messages are strings, right? So it's very simple. So when we get the message, we want to return the reverse version of the message, right? And it's easy as just calling this long chain of functions because JavaScript strings don't have a built-in reverse method. But now that we reverse the message, we can send it back through that same WebSocket with the call WebSocket send. So very simple, right? Only two things that we need to note here is that, handle the connection event on the entire WebSocket server, handle message events on a particular WebSocket connection, and of course, we'll be able to send messages onto the WebSocket through ws.send. And over here, it's just listening to localhost 8080 for requests. Yep. So this roughly illustrates how client-server application using WebSockets is structured. Now that we understand this, we can move on to a more complicated use case. And the first big app we're going to tackle with today, which is a simple group chat room, right? So as a demonstration, let me just show you the completed product. It's here. It takes a while to load. I should have opened this just now. Let's send the link here. Great. So if someone else could join the room, that would be nice. But, right. So now we have like multiple users, right, in the room. So it's like, hello. You just type hello. If you're observing right now, right, you'll also, yeah. If you're looking at the chat right now, you'll see the message push instantly to your client or to your browser. You can see that everyone has a unique identifier. It's like a two-word identifier. And then everyone has a flag right beside their name, right? Because we can find it out through the IP address, right? And then one last feature is, I wonder if this is profanity, right? One last feature is that there's a profanity blocker. So if I send a message with some profanity, yeah, I get a message saying the message contained profanity and was not sent. So these are the main features that we want for our application. So let's just go through how we can build this very quickly. So I've prepared a boilerplate application already. Over here, y'all can see the link. I'll just send it to the group. Have a drink. Okay. So now I've sent the link. Let's start by cloning the repository again. Just close it out. So we have a chat app starter, repository with the boilerplate code. I have had it I have most of the things already implemented. So all we need to do is to hook it up to WebSockets, send the appropriate messages, right? So just to briefly go through, right? We want to build a group chat room with this behavior. When the user enters the room, the user is assigned a random username. The admin bot will inform everyone that this user has joined the room. The user is added to the display of online users. When the user sends a message, first, since we think we want this to be a PG place, we first run a profanity check on the send message. If there's no profanity, then we can send a message to the group. Every other user in the group can see it. If there is profanity, admin bot will send the message to the offending user, telling them that, oh no, this message is profanity, so the message is not sent. And when the user leaves the room, the admin bot sends a message to everyone in the group informing that the user has left the room and the user is removed from the display. And lastly, we want to display the user's origin country, which find out from their IP addresses, and then to update the number of active users currently in the chat. So this repository over here has the following directory structure. I wonder if it's clear. Has roughly this structure. So, oh yeah, I missed it. The name's wrong, but okay. Right, there's node modules with the dependencies, a public folder containing the front-end code, a source directory containing the backend code, and app.js, which is the entry point to the app. entry point to that here, right? Okay, right. So I've already implemented most of the code, but you can look around the repository to understand how the application works. And today we only need to modify 2 files to get a full working application. Right. So before we start, let's install dependencies. Since I just cloned it, I'll just quickly install the dependencies right now. Everything's installed. I've installed. Oh dear. Oh boy. I should have known this would happen. Hmm. Hmm. Should we move this to? Okay, no problem. If you're having any issues like me, it's because I have a few dependencies in there that don't run very well. I'm just gonna push an update right now. All right. So now I just start a server. So we started a server. This is a very simple bare bones front end. It's connected to the server. It's not actually doing anything right now. So you can see like things aren't updating. If I open a new tab, nothing really updates. And if I open my dev tools, it's not screaming at me. Okay, that's pretty good. But yeah, it's not working, it's not functioning. Typing in a message doesn't do shit. So this is the rough structure of that. Now let's go through what's going on, what we have, what we don't have, right? So to roughly go through, we'll start from the server side, right? So our entry point to the application is app.js. It's the same as the simple server that we had just now. We have our internal dependencies, our external dependencies. We have some additional packages. A heartbeat is basically a mechanism for us to detect disconnection. Yeah, involuntary disconnects. Messaging is the crux of today's course. Then we serve the static web page in public with Express. We'll talk about it later. And then our WebSocket will start our WebSocket server. We will attach all our event handlers, right? So on the back end, right, I created some utility classes just for ease of programming. So we have a user class with the associated WebSocket, the user's username, the IP, and their country. And then just for simplicity, I have a getter on here that returns the visible attributes. So things that aren't the sensitive information like the WebSocket. Right. So utils is just utility functions. So over here, I have a simple utility function to get the country code from the IP address of the user. I won't cover what it is, how exactly it works. But it's very simply just calling the geo plugin API. Contains profanity is the similar. It just calls an API that checks for profanity. Heartbeat is just sending Pong messages to make sure that the client on the other side is still alive. If it's not alive, we'll emit a disconnection event. This we will use later to detect when someone disconnects and then do the appropriate thing, right? Tell everybody someone has left the chat room. But the main part is the messaging JS. So over here, it's similar to our simple server just now, but with a few additional things. So we have niceware, which generates the random passphrases, which act as the user IDs. Moment.js is just a library to handle timestamps. Our internal modules, utilities, and classes. And then here we have a large bind, which will be called on the WebSocket server. And then we will listen to the connection event. But here, we have a users object, a big fat users object to manage the users in the room, just to act as a sort of a dictionary to manage the users. And here we'll call the on connection, and then we'll do all the good stuff here. And here's a utility function called broadcast, which just takes two values, a sender and a message. So it will send via WebSockets a message to every user except for the sender. And then if the sender is nil, it will send the message to every user, right? It broadcasts. All right, so that's the backend setup. Let's go look at our front end files. It's pretty basic stuff. Actually, it's not very basic stuff. There's a lot of stuff. But what we're concerned with will be the utils JS here, which just contains a bunch of utility functions that allow us to manipulate the DOM, which just helps us more quickly do up our UI interactions. So you don't need to think about them we don't need to think about how to make certain things appear, disappear. We just need to call these methods. So if, for example, say if I wanted to add a user, or add user, username, country. So country is a 2-letter country code. So add user adds a user to the sidebar. Remove user does the reverse. Removes it. It's like not really maintaining any state, right? Clear user clears everything here. Add user count changes the this count over here. So changes this here. Add admin message. What add admin message does. Add admin message. Adds an admin message like this. Adding a user message. Just same thing. Add user message. As a text field. And of course has its user field. So this user just just tells it whether to oops, I messed up. Add user message, sorry. Add user message adds a message here. If we set this user to false, it will show up on the left side instead. That's all. Simple. So these utility messages, utility functions rather, we can now move on to building the application, right? So let's go at it step by step. We've already illustrated what we have, how we start in the code. In fact, a lot of today's workshop will be actually uncommenting things. and just making sure we get things right? So let's go through the flow a bit. Let's go to step one. Step one happens in messaging.js. So we're right now in the WebSocket server on connection. So this function is called when a new connection is made to the WebSocket server, right? We generate a unique two-word passphrase. And then with this request object, we get the header, the IP header, the header of the client, which just tells us the IP address. And then we already call the utility method to get the country code. And we have the current timestamp. And we create a new user. Since the user information stored on the server side will be the username, the IP address, and the country. That'll be all. So we can create a new user and then add this new user to our dictionary of users over here. I say dictionary because it's a Python term, but it's a JavaScript object dictionary. They're different, but I'm using it like a Python dictionary. So what we first want to do, right, is when the user first connects to the WebSocket server, we want to send the user details. So how do we send these details, right? So like I said just now, right? WebSocket messages are just plain strings or raw data, right? There is no type to these messages. So how can we enforce a bit of typing to the type? How does the client tell that this message is a particular type of message? There's only really one way, which is to send a JSON string, right? So in the absence of the framework, or rather the protocol allowing us to send messages of different types, we have to come up with our own message schemas. So over here, we'll just define at the start some of the schemas used in these applications. And it's important that once we define these schemas, we stick to them. If not, things get messy. It's not very good, right? So for client to server messages, clients don't really need to do anything to the server. They just need to send messages. So there's a message from user with the text, some text, right? Based on the WebSocket connection, the server already knows the identity of the user. So it's fine, right? But then for server to client messages, we need to handle a lot of use cases. So let's go through them one by one, right? So at the start, when the user first joins the chat room, the user has not been assigned a username. They don't really know their country, or So the server needs to tell the client, this is your username, this is the flag you should put on. So we use the welcome message for it. We'll just call it of type welcome. So how we distinguish between messages on the client side is that we will, this will be a JSON string. It'll be sent over. We deserialize it. We pass it, deserialize it, and then check the type of message. And that's how we tell the type, tell the difference between different messages, right? So we'll just have a welcome message with a timestamp, and then this receiver field just tells the user, this is your user information. The update state message, we'll use it by the server. The server will use it to tell the client about the state of the chat room. So who's in the chat room, who's not. So this is type update state. The state object, inside state object, we have a users object, which is users array, which is just an array of users. So users, to the client, the user is comprises of two attributes, a username and then a country. And then last, error messages. We have a few more. Error messages, the server uses it to tell the client that something went wrong. Type error and with a message field. Admin message, this is just to make an announcement. Same format as the admin message. And lastly, a user message. The user message should include another field. Sorry. A user message has an additional field. User message should have another field. No. It should have a username, country, and text field. Country, text field. Username, country, text. It should have a username and country field as well. So it should have a username field. Country field. And then of course a text field. Sorry. And the text. Oops. Sorry, it's a sender field. And text field. Might be. All right, let's get back to this. That was embarrassing. But sender field and a text field. Right. I'm just gonna double check, make sure I got everything right. Admin message. Oh, it's a text field, not a message field. Sorry. My bad. It's a text field, not a message field. Yeah, but this is a user message. The server tells the client, okay, this user sent the message to the chat room. So that'll be all. So let's start step by step, right? From the users, from the server side. So step one, when the user first connects to the WebSocket server, so you see it's inside this connection event. The user just new user is connected to the WebSocket server. We've created a username for them. We found out their IP. We found out the country. We have a timestamp, right? So now we want to send the user their user details, right? So how do we do that? We just simply, again, like just now, we learned that we can send messages through WebSocket using WebSocket.send, ws.send, right? So just calling the send method on the WebSocket object. So now this will send a welcome message. And then it'll tell the user, okay, these are your details, right? Next, we need to update the users, all users actually, with a list of currently active users. So we'll call broadcast. Remember here, broadcast, what broadcast does is that, broadcast now does, is that it will send a message to every WebSocket other than the user, the sender. So we'll send everyone this update state message with the state, updated state. And this extremely long statement here basically returns an array of all the user objects within the, well here, up here, this user's object here. Then we'll send, or rather we'll broadcast the admin message to everyone. Let's say, okay, this username has joined the chat. Easy peasy, it's just a bunch of messages sending. Next, what happens when a client sends a message? First, you need to check the message for profanity, right? So, well, first we need to get the text, right? So this payload here is a JSON string. It's serialized, so we need to deserialize it. So we do that with json.parse. input. Then to get the actual text message, we remember that it's on this text property attribute, which is called text. Right, then that's all. Right, we have the text. Now I'm going to check if it contains profanity. So to check if it contains profanity, we just call utils dot contains profanity and with the text. Now remember, over here, utils dot check contains profanity is an async function. So if to get this to work properly, we need to use await here. Now if there is profanity, then we want to send a message only to the user. So if contains profanity, send a message to the user. So we send them an error message with a timestamp. See, we have the timestamp here. And let's figure out what text should we send, right? We have the message, so we'll just inform them this message contains profanity and not sent. If there's no profanity, okay, if it contains profanity, send a message and we'll just return it here. If there's no profanity, then we will broadcast it to everyone. So the text will be this text. So next, on disconnect, when the user disconnects from the WebSocket server, we just want to tell everyone that someone has left, right? So we just when someone disconnects, we want to update everyone with the state. So how do we get a state? Remember just now over here, this is how we get a state from the users object over here, right? So we've already deleted the users from here. We deleted the disconnected user from this user's object over here. So I just need to convert it to a form, convert it to an array instead of an object. And then just tell everyone broadcast to everyone this user has left the room. And I think that's all. That's all we need to do for the server side. Easy. I mean, it's a lot of uncommenting, but the flow is very simple. So now let's move on to the client side where we'll handle, the messages coming in, right? So remember just now we have 5 different types of server to client messages. So now let's start to handle them one by one, right? So on the client side, we store the client's information in this myUser object, which is initially empty at the start. So on welcome, when the client receives his username and country, we'll just set it as such. On update state, what happens is we get the users. We get the users from the new state, right? The state from the server. Update the user count, clear the sidebar, and then insert the users one by one back into the sidebar. When we have an error, we just want to add an admin message. Then when we get a user message, we'll call our add user message over here. So that'll be all the events that we need to handle. Now let's handle sending information to the server, right? Sending information to the server happens when you click on this form. So over here, if I start the server, Sending a message just happens when I enter this form, right? So what we want to do is that when we submit this form, we will send the message through the WebSocket connection, and then display it on our own cell on our side. Yeah, that will be all actually. Okay, something has gone horribly wrong. Let's find out what happened. This user. Oh, right. It's probably happening on the server side. Oh, no. User message. Over here we messed up. So the client is receiving all the clients because I broadcast now. So this message is being sent to all client WebSockets. So I just exclude this particular user's one. So I will take user. This should be all fine and dandy. Look here. Server. Right. Just put this to the side. So we have the behavior. This user leaves the room. It's updated. Sidebar is updated. And yeah, that's, it's not a very complicated web application. We just need to figure out what we need to send it appropriately. That's all. So this brings us to the end of the first part, right? So since we have, since we're running out of time, we might not go through browser APIs. We'll save it if we have time at the end. I think Daryll, you ready?
Yeah.
So Daryll will now go through, some basics about WebRTC.
Okay, so hi everybody. So I'll go through introduction to WebRTC, which is another interesting technology, right? Yeah. So this one. Just a minute. All right, let's start. Okay, maybe some of y'all have heard of this WebRTC before. I mean, if you have heard of WebSockets, maybe WebRTC is familiar. So what is WebRTC? I have copied and pasted this from Mozilla. This is the definition that Mozilla gave. It's an open source project that provides web browsers with real-time communication via simple APIs. So it's really a HTML5 specification, same as WebSockets. And really, right, essentially, it's an open source specification that developers follow, and there's a good set of APIs to do this job. And I think if you're wondering, how different is WebRTC from WebSockets, I think the key gist here is to understand what it is being utilized for, right? Generally, WebRTC is used for like real-time communications, and if you think about it, right, technically, it is feasible to try to do this job, with just WebSockets, right, to do media communication. But if you remember what Lowen has shared, right, communication like has to go through a central server, and this would kind of introduce some latency. So it is not really the best protocol to do this job, but I will introduce more later afterwards. Yeah. So let's go. Yeah. So let's see what we can do with WebRTC, right? We can have real-time video call communications, as you may have, interacted with before. Google Meets, stuff like Google Meets, Google Hangouts, your Discord, your audio and video, communication channels. All these actually implement WebRTC under the hood. So it's really interesting what this technology can do for you. And if you want to go further, you can even have some multiplayer games like having some simple FPS game or even web VR and all that kind of things. So there's really quite a variety of things you could do with WebRTC. But if you look at all these applications, right, there's some common themes, right? If you understand, it needs to be real time, and they are heavy on the audio and video side. So this is really what makes WebRTC special and needed, right? So I think before I go further into WebRTC, yeah. So like what I said, real time audio and video applications. So yeah, before I go further into WebRTC, I think it's good for me to give a comparison between WebSockets and WebRTC, because I think you might have some questions in your head, right? So this is a good broad overview of the comparisons. So for WebSockets, right, the clients have a persistent bidirectional TCP connection to the server. Yeah, so you can see persistent TCP connection, and WebRTC is a real-time communications, and WebSockets. I think the key here is to understand that WebSockets have low latency, but WebRTC even lower latency, such that it's close to real-time. And why it is able to achieve this, it's really because WebSockets uses TCP while WebRTC uses UDP, which is essentially faster, but there may be some compromises, right, in terms of reliability of data transfer. So that is something that we have to consider. So in terms of applications, you can see the kind of differences, right? So for WebSockets, it's more of you send something over like one shot like chat rooms, you send a message to the server and all that. File transfer is a one-shot kind of thing. But for WebRTC, you look at the applications, it's a constant stream of data, a real-time stream of data, streaming, video calls, multiplayer games, and all that. Yeah. So so let me just show you again, what WebRTC WebSocket looks like broadly. So for WebSockets, clients, they have a persistent bidirectional TCP connection with the server. So everything has to really go through the server. So for instance, if client A wants to send something to client B, client A has to send to the server first, and the server will help to relay this down to client B. So there's the server acting as the intermediary over here. So that is WebSockets, right? So let us now look at WebRTC. This is what it will look like broadly, right? So the clients would still be linked to a central server, but eventually, right, the clients could send information to one another directly. So this is how it looks like broadly, but let us just deep dive and see how it actually works. So in terms of step one, right, initially if a client wants to establish a peer-to-peer connection with another client, right, there will be a signaling process would occur, right, and this is handled by a third-party server. So this third-party server would help to coordinate connection information between the clients, and help the clients find each other through their IP addresses and all that. And once the client knows how to connect to each other directly, the clients can just establish a direct peer-to-peer connection and to exchange real-time media information with one another without the server. But this is still kind of broad, right? So let me deep dive into the technology used actually, right? So I mean, previously that was just a broad idea of the signaling process. So in practice, right? In practice, client applications actually need to traverse through, the different NAT gateways and firewalls to get to each other to find out their IP addresses and all that. And to aid in this, right, there's something called the ICE protocol. So ICE stands for the Interactive Connectivity Establishment. So, and it defines a kind of like a systematic way to find the optimal communication option between the two channels, endpoints, right, through the different NATs and firewalls, and including using relays as necessary. So, so that is it. And there are here two options to help to establish this peer-to-peer connection. One is stun, and one is turn, which you have seen over here, right? So firstly, right, stun will be used. Stun server will be used, and stun refers to session traversal utilities for NAT, right? So what happens is, right, the stun servers will try to get the public IP addresses of the different client browsers. And if it is able to do so, that's good, right? So the clients can just take this information and connect and have establish a peer-to-peer with one another. But if it's no, but the issue comes when, right, in some NAT implementations, right, where there are so many layers and firewalls and all that, the stun process may not be that good enough, right, to do this job. So, for instance, right, some browsers using NAT may employ a restriction called symmetric NAT, right? So that's when, if the stun servers can't do the job, that's when we have to rely on the turn servers, right? So turn stands for traversal using relays around NAT, okay? So these turn servers essentially help us to bypass this symmetric NAT restriction, and it helps to facilitate conversations between the peers behind different NAT firewalls. And yeah, so what it does, right, is it acts as a relay, intermediate relay server between the client servers, where it will help to receive information from one client and then help to forward this information, this media, to the other client. So let me repeat that again. The turn servers will help to receive the media information, the media data packets from one client, and help to forward this to the other client. So this is what the turn servers do. And if you realize, right, it is not really a true peer-to-peer connection anymore. But yeah, it is not a true peer-to-peer anymore. But this is just a backup kind of a server if stun servers are unable to do the job, right? So if you can imagine this, right, the turn servers have to receive the media packets and then send it over to the other client. So if you can imagine, there's a lot of server work for this turn server because a lot of data traffic flows through this relay server. So what it actually means is it is very expensive and costly to try to have these turn servers running, right, in terms of server costs and all that. So I think practically, this is why many cloud providers don't really offer a free turn servers. There's no free tier for this. So that is something to keep in mind, right? So this is why this is just a backup in case the stun servers doesn't work. So that is how this whole thing WebRTC kind of works. But WebRTC is not just whatever I've mentioned earlier. There's actually a lot of other things in WebRTC as well, and why it's so beneficial, right? So there's stuff like signal processing to remove the ambient noise from the audio video feed. There's also codec handling to compress and decompress data. There's also routing through the ICE protocol, and the user data is also automatically encrypted before transmitting across the connections, and there's some kind of managing of bandwidth as well. So there's a lot of other small features in WebRTC, right? So now let us go through, what are the challenges, right? Because I made WebRTC sound like it's so good. So what are some of the challenges? I think the number one consideration is WebRTC actually uses UDP. So what this means is it is not a reliable data transfer protocol, and if it is important in the application, right, then you need to think twice, right? Yeah, about it. And yeah, so, and there's also no standard signaling protocol, right? As to how or which server, which IP address, all this. So all this has to be um, coded by yourself, and which is why WebRTC may be a bit complicated to deal with on your own if you if you directly use the WebRTC APIs. It might be a bit complex, which is why there are which is why there are companies and developers usually use wrapper libraries like PRJS or like EasyRTC, all this. So all these open source libraries make it slightly easier to deal with or WebRTC behind hook. So, and another thing is it may not be fully compatible with all browsers as well. For modern versions of Chrome and Firefox, it is okay, but for other older browsers, and if like Edge and Safari and all that, WebRTC may have there may be some compatibility issues, right? So in that case, some extra plugins may be needed. So, which is also why PureJS is very popular because it kind of handles the this kind of browser complications of the older browsers. Okay, so the key reason to understand is why use WebRTC, right? Why should you use this in your application, right? It is really, I think the key gist is it's really great for services that need to be real time and it needs to be fast, right? So that is the most important key consideration, and and it's good because there's no third party apps involved, no need to install additional software, and it's really embedded in your web technologies. It's a HTML5 specification, so all these applications can just run directly on the browser. Nothing is needed to be installed, right? And generally, it is also secure, right? Because it runs inside your browser without any additional processes, and less chance for spyware, malware, all that. And I mean, right off the hood, there's also end-to-end encryption as well. When you send the data packages, so there's no spying. There's less chance of spying involved over here. So I think this is the gist of this whole WebRTC explanation. I would proceed on to show you a tutorial of a video call application I've created. All right. So let me show you over here. So let us see how this works, right? So I have a application deployed on Heroku already, and so this is the application that I've deployed on Heroku, and it automatically redirects me to a room with the hashes behind the UUID. And there's an alert tell me to copy paste this into another browser, right? Sorry, let me re-share the screen. Yeah, sorry, give me a minute. Let me share the screen. Okay. I need to close this entire screen. Okay, thanks. Okay. What's...
I think your network connection.
So
you are connected to Wi-Fi, is it?
No, it's... Oh yeah, Wi-Fi. Yeah, so give me a moment. Let me just quickly...
Just confirm that you are still connected to the LI guest for your Wi-Fi.
Should be...
Okay, then can you press the Windows K key?
Yeah, meanwhile, you guys can go to the GitHub. Okay, all right, that's good. Sorry for the delay. Yeah, so let me show you the application I've deployed on Heroku. Yeah, so this is the application over here, and let me off the mute. Let me mute this audio first. If not, there might be some echoes and all that. So let me copy this room link and open it somewhere else. All right. Yeah, so you can see over here, I have two clients open up, and they can see one another. Yeah. So this is roughly what you would be developing, right? So let me close this, and let's go to the GitHub repository over here. So it's Realtime Apps IAP video call app. Okay. Let me push this to the side. So let us clone this repository. Okay. Okay. All right. Yeah, let us open this up. Okay. And we should see this repository with this code structure. So if we were to take a quick look at the package.json, it's very simple, right? There's over here, I'm just using a very simple templating engine, EJS, Express, Server, NodeMod, Peer. Peer.js is what I'll be using. It's a WebRTC wrapper library that makes things really simple, just really simple, and it kind of feels like WebSockets. And over here, I'm using socket.io as well. Another wrapper library for WebSockets makes things really simple, and UUID. And there are two scripts, start and dev. Start just runs server.js, and dev will be running on NodeMon. So I think for ease, I'll just run my terminal here as well. Let us install the dependencies. Yarn. All right, so I think so. Let us see what branches I actually have. Actually, let me jump start first. Just a very quick test on the server that we have. This repository, quick test. Yep, so let me go local. Let's test that this works, right? Now and allow, Yep, so this works. Let me copy this link and let me paste it elsewhere. Yeah, so this works. So if I close this, right, it should be gone. So, okay, this works good. So this is what we will be building, but let us go back to the code. Okay, let us stop this. So let us go to let's see the available branches. So I have a couple of branches over here, and let's go to the tutorial branch, right, which is what we'll be using for today. So let's go git checkout tutorial. Okay, all right. So I've over here with this tutorial branch, I've made things really, really simple. It is just the original or main branch repository, but I've uncommented out parts of the code. And then I've just made it really simple. You just have to follow and uncomment it out together. Okay? All right, so let us see what we have over here. We have our main server code over here. So this is our main server code. It runs on port 5000, and it and it passes our public repository, and this is just a templating engine EJS, right? So, and we also have a pure.js server running, right? The pure.js is really our WebRTC, and it does all the signaling processes and all that. So this runs at the path pure.js. So the rest is really just if it's a root link, it will just redirect to a random UUID over here, and then because we are using this templating engine, right, we can do something really, really cool. So we can just pass a variable room ID. So over here, I passed the room ID, which is essentially this user ID. So I've passed it to the web page. So over at my web page in my JavaScript, I can just take out this room ID variable, and let us take a look at the rest, right? So this is the room EJS over here. And it's quite simple, right? Yeah, so this is what I meant. Over here, I can just take it out, room ID, and it's named as room ID, room_ID. So this is okay. Let's now look at this. So our public file, right? This is the main JS is what we want to look at as well. So essentially, the two main files for this project is main.js and server.js, right? So main.js runs on the client side, okay? Main.js runs on client side and server.js runs on the server side. Okay, so let us follow the to-dos, right? So I've included the to-dos. So let us follow one by one. Let's go to to-do one. All right. So this runs on the client side. So what happens over here is on the client side, you initialize a new peer. So this peer object just really helps us to interact with the pure.js server on the server side. So if we don't input any parameters inside, it will just run the original parameters, like going to the pure.js path and the normal host, and automatically you'll find the pod, right? So let us go to-do one. All right, so over here, what happens is I think Lowen has shared this browser API just now. So what this does is it will request for permission to on the browser to on the video and audio feed, because I indicated both as true, and then in this stream, and then I'll add this to my video stream. Let us just take a quick look at what is add video stream, right? Add video stream just takes this stream, and then once it's fully loaded, you'll play, and then just you append this to the website HTML. So this is what it does. So let's look at to-do one. What we have to do now, right? So we have to connect to the new user who has joined the room, right? So before that, let's take a look at server.js. What happens? So if you look at server.js, right, it actually has a socket, right? If someone connects to the server, right, the socket would you would request it to join the room, and then it will actually emit to all connected sockets that, hey, a user has connected. And then on the client side, if we see, so on the client side, what we have to do is, if a new user has joined the room, what we want to do is we want to connect to this new user. So this is to-do one. Let us uncomment this. Right, so let us run this. Run start. Let's run this, okay? Yeah, let's use the node mon, okay? So if things are going on right, so let's just open. Okay, let's just put it side by side over here. So if it works, right, if another client joins, right, another client joins, if client B joins, right, the room, yes, client A should get a console log over here. Someone has joined the room. Okay, so this is what we want to see, because in the code, this is what we did, right? It logs the user ID of this user that has joined the room, and that works fine. Okay, so why isn't the video feed shown over here? Why isn't the video feed shown over here? It's because we haven't connected to we haven't actually connected to this new user. What we have done is only just to print out console log the user ID. That's all. So we have to connect. The to-do two is to connect to this new user actually. And what is this function? Let's take a look at this. Right. So what this does is it actually tries to call this peer, right? Because now with that peer's client B's user ID, I can as client A, I can directly call and connect to client B. And if you look at it, if you see over here, and peer.js really makes everything really simple, right? We just have to call, and it kind of works like WebSockets, but of course there's more under the hood, right? All the signaling process and all that. So for us, it makes things really simple. We just have to call the user, right, and then pass him client B our stream, right? And then so this is connect to new user, and let's look at to-do 3. So because previously we passed our stream to the client B, so what would client B have to do with this stream, right? It is over here. So when client passes me the stream, right? When client calls me, when client A calls client B, client B would answer. Client B would actually pass back. Client B would pass its own stream to client A. So this is what happens over here. You answer and pass the stream to client A, right? And then for of course, when I take the stream, when client B takes the video stream from client A, what client B wants to do is I want to display this stream on my own client website, right? So this is to do 4 over here. So when I receive the stream, I want to show it on my own feed, which is why we have this add video stream over here, and this is the function that I've introduced earlier. So this will actually add the video to appear on my browser. Okay, so so let us save this. All right, command helps us to restart the server. All right, let's see if we have missed out anything. To do 5. Okay, so I think let's try this again. All right, let's refresh this. Oops. Yep, so this is client A. Let's name this as client A. Okay. I think there are some problems with the video webcam on this laptop, but let us. No, it's okay. Yeah. So let's imagine that this is already there. Okay. Let me just try again. Yeah, I'm quite sure this has no problem, but I think it's just this hardware component on this laptop. Yeah, no worries, no worries. Just let us copy this, and let us open client B, right? Client B, and let's see if the behavior is what we expect. So it seems like it's not working as what we intended through. Let us see what's wrong, okay? Okay, so I see the problem here, right? So when we connect to the user, right? When client A calls client B, okay? And if client A receives a stream from client B, I did not add this video to my own browser, client-side browser. So this is the part where we are missing, right? I want to show this I want to add this video stream to my own browser. So let us try again. Yeah, that should be the missing part. Okay, I'm not sure if this is a hardware problem or if not, it should actually work okay. Yeah, so this works, right? I think it's a hardware problem just now because Lowen mentioned that his webcam isn't that good. Okay, so this actually works perfectly, right? This is what we want. So let us try to, let's say client B, client B closes the browser and logs out of all of this. And let's look at the behavior of this. If we see this is not what we want, right? Client B has exited, but somehow the video feed looks a bit weird. Okay, so let us see if we have handled this well. So we have done to do 1, 2, 3, 4. Now we are at to do 5, right? Which is what we have not handled yet. So when the user disconnects, right? When the user closes his browser or end the call or whatever, right? We want to handle that. Okay, so when the socket disconnects, we want to do something. We want to tell everyone that, hey, this client has exited. Hey, everyone, please do something. So this is what we want to do, right? So our server will broadcast this to everyone. User disconnected. This event, user disconnected, and let us take a look at what is this, right? So user disconnected. We want to be able to handle this user disconnected, right? So this is where we handle this. When the user disconnects, when I know that, so if I'm a client and I know that client Z has disconnected, what I want to do is simply just close the connection to client Z. As simple as that, right? So this is where it's being handled, right? So when the user is disconnected, we want to close this call, right? We want to stop this call, and this is where we handle this. And essentially, this is what we actually need to do, right? I think we have gone through everything, and it should actually work very perfectly well, I think. Hopefully, right? So let us try. Of course, there are some hardware problems with Lowen's webcam, so let us look at this, if it works. Yeah, so this works well now, right? So there's 2 video feeds. And let's see when client B exits, right? When client B exits, we want the video feed of client A to stop and exit, right? Let's try again, okay? It should honestly work. Okay, so like, I think there are some issues with the webcam, right? It's not really doing. Let's try again. Yeah, I think there are some problems with the webcam, right? But essentially, what we should be able to see is, yeah, there are some issues with webcam, as you can see. So let's get this working, right? So if I close this, right, it should work well, okay? But yeah, I think okay. So yeah, I think we have covered everything, and it should actually work well. So yeah, so the user has disconnected. This should be gone actually. Okay, just keep that in mind. So I think we are actually done for today. So let me actually go through some other functions that we have over here. I mean, these are just more of cosmetic functions, right? Muting your audio feed. You can see over here, mute and unmute. Set mute button. And stopping your video feed. So these are more fun stuff, right? And there's also an end video feed button. So yeah, so I think we have actually gone through everything for today, and thanks for today. So let us go back to this slide. So you can see, right, how WebRTC can be quite pretty fun. You can build your own Zoom application, video call application, and even game application. So yeah, but let me go back to let me show you very quickly first some game application that when we conducted this workshop previously, right? Some of our participants actually joined our competition, and they actually created some really cool applications with WebSocket and WebRTC. So, for instance, this interactive real-time bot. Someone created this is a WebSocket implementation as well as a 17. So I think you guys can explore this yourself. But so this is really cool, just to put it out there. So yeah, let us go back to these slides, right? So yes, I'm done with the tutorial. And yeah, so I would like to, we are done with the tutorial, and yeah, so here's a word from our location sponsor who so graciously sponsored this location that we are presenting over here. So yeah, so skills training, yes. Okay, skills training, and yeah, any feedback, please give us your feedback as well for skills training workshop, skills future. Okay, and you're good for today? Okay, so thank you very much, everyone. So I think we are good for today, and really, Lowen and I both appreciate your time, and I think it's really good. We are really happy to be here to present to you guys our knowledge and our passion. So I think we would love to hear feedback as well. So if you have any feedback, just give us some feedback as well. Yeah.
So yeah. So I think that's the end for today. Maybe we'll be hanging around for a couple minutes more. If you have any other questions, anything you want to ask, or you want to get connected, maybe just like ping us on chat, right?
Ciao.
Maybe you should
Why can't you ask for the tours?
Huh? I think it's fine. Yeah.